we'll start by creating a basic sketch using the required dimensions. Every precision step begins with designing our bevel gear. Every perfect tool path begins with the right strategy. Welcome to CNC Design Labs, where precision meets innovation. Today, we'll design a professional bevel gear in SolidWorks from start to finish. Welcome to CNC Design Labs. We'll start by creating a basic sketch using the required dimensions. This is the first step in designing our bevel gear in SolidWorks. As shown in the video, we'll fully define the sketch by adding the required dimensions and sketch relations. A fully defined sketch is more accurate, stable, and easier to modify. This step ensures that all geometry is properly constrained and ready for the next stage of the bevel gear design. Define the dimensions as shown in the video. Now, we'll use the Revolve feature in SolidWorks to create the 3D shape from our 2D sketch. By selecting the required axis and rotating the profile through 360 degrees, the basic body of the bevel gear is generated. This feature helps create accurate symmetrical components and provides the foundation for adding gear teeth and other details in the next steps. Now, we'll start creating the bevel gear shape in SolidWorks. Using the required dimensions and reference geometry, we will develop the tapered gear profile. This step defines the main shape of the bevel gear and prepares the model for creating accurate teeth and final design details. As shown in the video, we are now creating the bevel gear tooth profile. Using the required dimensions and sketch tools, the tooth shape is drawn accurately on the gear surface. This profile will define the cutting shape and ensure proper engagement between the gear teeth during operation. Now, we will trim the unwanted curves from the sketch. Using the Trim Entities tool in SolidWorks, unnecessary lines and extra geometry are removed to create a clean and accurate tooth profile. This helps maintain the correct shape and prepares the model for the next feature. Now, we will use the circular pattern feature in SolidWorks to create the remaining gear teeth. By selecting the tooth feature and rotating it around the center axis, the pattern is repeated evenly around the gear. This creates the complete bevel gear tooth profile with accurate spacing. We will create a new reference plane and position it at the required offset distance from the original surface. Using this plane, the previous tooth geometry is copied and scaled to achieve the correct tapered profile. This step is important in bevel gear design because the tooth shape changes along the gear length. By adjusting the copied entities and maintaining proper alignment, we can create a smooth and accurate tapered gear tooth form that closely represents the final manufacturing geometry. Now, we will rotate the converted entities to create the required gear tooth profile. Using the Rotate Entities tool in SolidWorks, the geometry is positioned accurately around the reference point. This helps maintain the correct orientation and prepares the tooth shape for the next modeling operation. We will scale the converted entities by a factor of 0.75 in SolidWorks. This reduces the geometry size while maintaining the same shape and proportions. The scaled profile helps create the required tapered form of the bevel gear tooth. Hide the plane. We will create a new reference plane and repeat the same steps to build the smaller gear profile. By using the offset plane, copying the previous entities, rotating, and scaling the geometry, we can create the required smaller tooth shape. This process helps maintain accuracy and consistency while developing the complete bevel gear design. After creating all three reference planes and profiles, we will now use the Loft feature in SolidWorks to create the bevel gear tooth shape. By selecting the profiles in sequence, the Loft feature smoothly blends the geometry between each section. This creates the tapered tooth form and gives the bevel gear its accurate 3D shape. Now, we will create the shaft that connects with the bevel gear. Using the required dimensions, we will model the shaft and ensure proper alignment with the gear axis. This shaft will allow the bevel gear to rotate and transmit the required motion during operation. Now, we will create the shaft component that supports the bevel gear. First, a rectangle sketch is drawn on the selected plane with the required dimensions. After fully defining the sketch, the extrude feature is used to convert the 2D profile into a 3D solid body. Next, the created body is positioned and rotated around the shaft axis to achieve the correct alignment with the bevel gear. This ensures that the gear and shaft are properly connected and can transfer rotational motion smoothly during operation. The final alignment is checked before moving to the assembly stage. Now, we will extrude the rectangle sketch to create the required 3D shape. After applying the correct extrusion distance, the feature is rotated around the selected axis to achieve the desired position. This step helps create the shaft geometry and ensures proper alignment with the bevel gear assembly. Now, we will create a circular sketch on the selected face of the shaft. Using the Circle tool in SolidWorks, we define the required diameter and position it accurately with the help of dimensions and constraints. After completing the sketch, we will use the Extrude Cut feature to remove the inner material. This operation creates a hollow section inside the shaft, reducing unnecessary material while machining. This completes our bevel gear design in SolidWorks. Throughout this process, we explored sketching, modeling, and advanced features to create a detailed mechanical component. At CNC Design Labs, we share practical knowledge about CAD design, CM programming, CNC machining, and precision engineering. Our goal is to help engineers, machinists, and students improve their skills through real-world design and manufacturing concepts. If you enjoyed this video, subscribe to CNC Design Labs and join us for more professional design and machining content. Until next time, design, program, machine.